All right, on your paper, because some of us, no matter how many times I say this is on your paper, forget that it is. If we wanted to remember our algebra tiles, we have a little image that reminds us of our algebra tiles. Now, I doubt that we need them. If you really ever want algebra tiles, they live over there in the coffee cans that they've been in. They will stay over there until Math 7 starts to use them. But we're at the point of using equations. So, guys, here's our question. When will the chubby bunny weigh the same as the chubby kitty? Now, why can we say with certainty that they will eventually be equal? Ella, you just got back, so we're going to skip you for now. Will, can you tell us how we know that at a certain point my chubby bunny will be equal to my chubby kitty? Ooh, my bunny starts at 5, gains 3 pounds per year. My cat, and guys, you have every highlighter except for orange in your containers now, because I don't know where all my oranges keep going, but yeah, this is why you don't have orange right now. So wait, I think I agree with what you meant to say, but I think you said it wrong. The bunny actually has a quicker rate of gaining. It has a lower what? Has a lower start, right? Like the start weight. Hey, friends. So hopefully we're all doing this together because, you know, when I grade your homework, I'm expecting to see stuff up here. So the bunny. How could I write the equation Maddie to represent that bunny?
B equals
No.
Okay,
What do they start at?
5.
Okay. We can write that first, or you could write the rate first. What's its rate?
3.
Yeah, see why you don't need to pass? But it's 3 every year. What do we want to do? We want to make years X's or
Why?
don't make years Y, because that's going to confuse your brain of, wait a minute, I'm using B as my Y. So guys, you might want to make a little note here. B is taking the place of our Y. So I don't want to use Y, even though, like, so you could either use X. We already use M for the slope. We don't want to use anything that we've used for anything else. We could either use X, or, please stop guessing, we can use T. T for time is a nice, safe variable. So T for time, or you can just use X, but you could use T for time if you want. I don't know why you would use W. You can if you want, but I don't exactly know why. The cat. Gus, can you help me with the cat? Ooh, yeah, so what Gus was referencing is the little b, right, our lowercase b, our starting weight, that y-intercept, 19 plus how much per year? 1, and since we already used t, I'll use t again, but I'm actually going to write the other forms of this also. Guys, I kind of don't like t, because it looks like a plus.
And then you're going to put like a little dot, like just to like show that it's multiplication.
Now wait, what are we trying to solve when these two animals will be... When these two animals will be the same, or mathematically we would say when these two animals will be equal. So guys, we want to set up B equal to C. So we're going to fill in our equation for B, we're going to fill in our equation for C, and then we're going to algebra. Just do the algebra. We need to make a little theme song for algebra. Gonna do the same thing. We could have like backup singers. Be like, we're gonna do the same thing on both sides. Gonna do the same thing. Add or subtract. We're gonna do. Okay, never mind. So, what is the do the same things? Alex, what would you do first here as we start to algebra?
I would subtract x from both sides.
Subtract x. How many x?
1.
We gotta be specific, right? Minus 1x, because we like to deal with the x's first. On both sides. So now I got 5 equals... Wait, crap, no! 5 plus... Wait! Dog! Math and pen! Stop doing math and pen.
Yeah, just like do it over.
5 plus... No! This is what happens when you try to make up a theme song. 5 plus 2x equals... It was so good until it wasn't.
You can just throw 2x plus 5.
Hey, if you need Post-its, they're in the back of the room. I decided to quit putting so much in the bin. So remember, Post-its live back by the hole puncher. I'm going to throw a Post-it on here so I can keep doing my work vertically, but up to you guys if you want to put it somewhere else. Claire, what's the next thing we would do?
You can add 5 to 19.
Add 5?
Minus 5.
We could subtract 5 on both sides because it's a positive. Who needs 5 Nights at Freddy's when you have a singing math teacher? 19 minus 5. And now, Vivian, what are we going to do? On both sides. Oh, she already said both sides. And we get... What label would that 7 get? Turn to your neighbor and hopefully you agree. What label would that get?
Tea time.
It's tea time. I thought that wasn't till the afternoon. What is our time? We used T or we switched over to using X, but that was representing our time in years. So this would be 7 years. Now wait, okay, that begs the question. How chubby is that bunny after 7 years? How chubby, like how much do these animals weigh after that amount of time? Figure out how much they weigh. Figure out how much they weigh after 7 years. I've got hands up, but I want. Hopefully, you've turned to your neighbor and talked already. Beatrix, how could I figure out how chubby one of these animals is? What do I do? Oh. So since we said we know what X is, ooh, I appreciate that reminder because I need to circle back to why the table we talked about on last week was not good. 7 times 3 plus 5. Let's verify.
Because I did 7 times 3, which is how many years, and then I did that, and then that equaled 21 plus 5 is 26.
Hey friends, what label would this get? Anybody, what label would these numbers get? Pounds, because that's what else we were working in. The abbreviation for pounds is LBS. It relates back to Libras. Not zebras, Libras. Okay, not okay. This is again, hey guys. This is again equal values method, which is in your math notes. It was the chubby bunny and chubby kitty. Except this cat's on a scale, mad about it being weighed. Alright, so I want you and your teammate to try to solve this. Hey, hold up. Here's my offer. If you would like to highlight, you are welcome to send someone to the board and take over and start highlighting. Because you don't have it on your paper, you might want to highlight some things. Make sure you color code. Otherwise, highlighting doesn't really matter. I don't know. They're probably over here somewhere. They come over here and just...
Okay. Everyone? Which color do I use? Yellow, green, purple, pink, and blue. Purple. Okay. Purple. Post Falls High School in Idaho has 1,100 students.
Oh, she's like actually...
And it's going by 22 students per year. Rich? Okay. So...
Apparently. I don't really know what happened.
Year. Growing. And then we're gonna do... Oh, per. And then we're, and in Richmond, which is gonna be
Ooh,
another color.
change colors. I like that.
Thank you. Has
Oh no, Richmond.
1,900 students and is shrinking 5 to 8 per year. I'm sorry.
Yeah, people are moving out.
Okay. Without graphing, right, we'll let represent the population at Richmond High School, and another will let represent the population at Post Falls High School. Let X represent years and Y represent population. Okay.
So you could use Y for population, because a lot of times we replace Y. Hold on, I want to teach you guys something you don't learn until high school, but I think you'll appreciate knowing it. So instead of using just like B for bunny, C for cat, what we do is set up function notation. So instead of saying Y, if we're going to talk about post falls, we can say post falls with an input of X. And that is our Y. That takes the place of Y. This is what we call function notation. That's Y. So similarly for Richmond, we can say Richmond with an input of X. So you can use Y if you want. You could just use R if you want. This is how you're going to do it in high school, really next year, because next year's high school, man. So yeah, that's what I would use instead of Y. So for example, we could write R of X. So you want to take back over and write out the equation? No.
Okay. RX equals question mark?
Well, no, we can fill it in. What did they start with, and what are they growing or shrinking by?
So for let's do that one first. Post.
Or do you just want like? Well, I guess we're not ready for graph paper yet till we write these down. You got to tap yet.
Okay. X equals
1,000. Well, not X. That's what our population starts at. Remember, X is the amount of years.
So which is 1. Which
So
is 22
if
per year.
I
22
was
per
you,
year.
I'd be grabbing graph paper right now. Ugh. Graph paper. I'm out of my good graph paper. Hey friends, for real, there's really no doing this without writing it down. If I was going to write down an equation, Owen, can you help me with my either P of X or R of X? You tell me.
So with P of X, it would be, so your growth rate would be 22 students. So you'd have to write 22x.
Okay, so if we start with our growth rate, it's 22x.
And then you add 1,160 because it's growing.
Yeah, and they started at 1160, guys. Or you could have written this the other way around, 1160 plus 22x. It doesn't make a difference.
So that means that at x equals 0.
We have 1160, right? Yeah, if x equals 0, we have 1160. Great. What? What am I doing wrong?
Oh, no, you're not doing anything wrong. I was just going to
Hijack it? Okay, do you want to write the r equals? All right, go ahead and get the r equals that we would put on our graph paper.
What was it? 22.
Whoa, that was our p equals. Maybe we should just work on graph paper right now.
Finish. Let me finish.
Now remember, is anyone waiting for Maddie?
Yeah.
No, you can be doing your own work. You don't need to be waiting for Maddie.
No, because I already finished my own.
When will the schools have equal populations? When will the schools... Maddie, grab a seat, because I want to make sure you have this on graph paper too. And now you're trying to be too fancy.
Well,
It's just
no.
gonna take
It's
longer
the
than it
wrong
needs
color.
to.
It confuses people.
Yo,
It's
so
confusing.
either...
It is confusing.
Hey, either... There, less confusing because it's covered up. Either negative 15x plus 1900, or if you want to start with the number like written first of what we start with, and then what is happening. But what are we trying to solve? When will p of x, bless you, equal r of x? So p of x equal to r of x. All right, I should see some real good work written down as I come around for us trying to solve this. A table is not an efficient way to do this. We looked last week at if your answer is a partial value, a table is not helpful. Guys, those of you that have stopped working where I stopped writing, that's why I'm concerned, and I'm going to wait until you move on your own. We know what P of X is, fill it in. We know what R of X is, fill it in.
Hey, officer custodian, we've had a small little puddle of blood. It looks like maybe there was a big nosebleed right outside the evening.
Some of you often do not give yourself the chance to practice on your own. And that's what our homework is for, but also what class is for, so we can safely make mistakes. Will, quit waiting, try to do it on your own. I don't want to remove this, but I can minimize it if you need to be trying this on your own. Quit waiting for someone else to do it. This is your paper. I'm taking this. And that's your paper. We're practicing the same thing here, just with different numbers. guys, the reason we have to stop just using tables or anything like that is the real world doesn't work out nicely. Not everything happens at an exact year or an exact day. You probably are going to stop getting whole number answers. Welcome to high school math. Wait, you guys have the same answer? Oh, are those exclamation points? Don't do that, because exclamation points in math mean something.
Factorial.
Did you not know that they meant something?
Yeah, they definitely mean something.
Did you not learn that last year?
So the number 20!
Oh, God.
Like, with the exclamation point, if you go to math, no, for real. So 20, right, with the exclamation point, is actually, that's a enormous number. That means move the decimal to the right 18 times. So an easier number to look at is 5. 5 with the exclamation point is 5 times 4 times 3 times 2 times 1.
What? I'm confused.
So check it. 5 exclamation point. The exclamation point in math means something.
What about 100?
All right. So, Simon, what would I do first here?
Maybe try and change the X.
I have no idea what you mean. Try and change that. Like, are you saying like do something on both sides?
Yeah.
So, what do you want me to do on both sides?
Maybe plus 15x.
Yes, because if we have a positive and a negative variable value, we want to get rid of the negative. So we're going to add 15x on both sides. So now 1,160, which again, I make my ones fancy because I think it's easier to keep track of what they look like. 22 plus 15, 37x. I think just 1,900 over here. Ella, what now? Yeah, subtract 1160. We don't always have to say numbers right while we're working with them, but yeah, 1,160 or 1,160 you could get away with saying.
See, that's what I say, but then I always get I always butcher it.
37x is equal to, ooh, crap. I need some help. 800 minus 740. Thank you.
740.
Charlie, what do we do to finish this out?
Divide by 37.
And where? On both sides.
Have you ever had a
I mean, are you asking like when I was a child, did I give myself a theme song? That's a kind of personal question.
Wait, though? Did you?
740 divided by 37. Oh! Hey, it did come out to be a nice number. Wait. What label? Go back to the question. What were we solving for? Anybody? No. Years. Our X stood for years. So hold up, we're not done yet though. How many kids? Figure out how many kids. We need to plug the X back in.
So we need some problem.
No, you don't, because you have it written down. You can plug it into your Richmond, or you can plug it into your Post Falls, because they should be equal to each other. So 1160 plus 22 times 20 should be equal to 1900 plus negative 15 times 20. They should be equal, and they are, so we like it.
Bingo.
So both of the y's equal 1,600. 1,600. Charlie, I think I've lost you because we're still doing work. students. Guys, the equal values method says if you want to figure out when two things are gonna be equal, set up equations that use the same variable, like x for years. Then set them equal to each other, do the algebra, get your x, plug in, get your y. Questions? My question is, do we have another thing we need to solve, or is that pretty much everything I wanted to get to?
No.
One more, just for fun. Let's do this. I bet you can do this in like 2 minutes and then we still have free time.
Green.
F of x. I'm going to use F for ficus.
Oh my god. It's a ficus tree.
Maybe I'm just pushing the U in the omelet.
Hey guys, anyone guess why I used K for the oak tree?
For kilometers. For the height.
Do you really want to use O as a letter that we're using? Nah. Like, you could, but man, that's going to be real dangerous. Is that 0? Is that O? So an A, I mean, sure. But I normally choose either the first letter or the last letter of an object for the variable. So I'm going to say F of x for the ficus, K of x for the oak tree. Where did the oak tree start? On the ground. What is the height of the ground? 0. So the oak tree started at 0. So the ficus, 6 plus 1.5x. The oak tree, 0 plus 2x. Let's algebra.
On both sides.
On both sides. Do I need to write the 0 plus?
No.
Nope. What could I do first? Cora.
I subtracted the 1.5x from that side.
Yeah, you did, because that's the right thing to do. Mick. I know I gotta get this written down. There are 2 perfectly good options here. What do you want to do? Divide by 0.5. You're right. 100% right. What's the other option? Ahmad? You can also do multiply by 2 because we want to get to 1x. So you could say, hey, how do I get to 1x? I think multiplying by 2 is easier in my head, right? Because what's 6 times 2? That's a little easier to think about than 6 divided by 0.5. You'll get the same answer. It's just what's easier in my brain. So x equals 12, and what were we solving for? Years. And then to get our height, well, let's take that 12 up. Well, if we took the 12 and plugged it back in for the oak tree, yeah, I didn't mean for that to go that crazy up. But yeah, 2 times 12, so it'd be 24 feet tall. Right? So once we plug in the x, because once you have your x, you can plug it in and find your y. If you would like to stick, we have like a minute and a half left, but if you really have thoughts, you must share with me. You can stick around and talk about FNAF if you would like. Otherwise, it is time for lunch. Hold up! No, because I erased it and I want you to have that so it's a good reference point. Homework due tomorrow, 512 and 521. Here, for those of you playing along at home, we'll spin this way and show the homework board. Look at that. Homework board. Do your homework.
Wait, no. What?